Lesson 8.6 talks about parametric equations, graphs, and applications. For 8.6, we're going to take a look at what parametric equations are and what do they represent. So, parametric equations of a plane curve. As a definition, a plane curve is a set of points x and y such that x is equal to f of t, y is equal to g of t, and f of and g are both defined on the interval I. The equations x equals f of t and y equals g of t are parametric equations with parameter t. If you want to solve these problems using graphing calculators are capable of graphing plane curves defined by parametric equations, but the calculator must be set to parametric mode. First, we're going to study this example, but we're not going to handle it with a calculator, but we're going to actually learn how to solve it algebraically. So if the question says x is equal to t squared and y is equal to 2t plus 3 for t in this given interval from -3 to +3, can you graph the set of ordered pairs x comma y? To answer this question, we're going to make a table of corresponding values of t, x, and y over the domain of the t. Domain of the t is whatever the given interval for the t is. Then we're going to place these points on the rectangular coordinate system to understand the curve. So the t values are going to change from -3 to +3. So these are the possible integer t values from -3 to +3. Since x has been defined as t squared, so for x values, we're just going to square these numbers and then we will find the x values. For y has been defined as 2t plus 3. So for each t value, we're going to multiply them by 2 and add the 3. So we will find the corresponding y values. So we have the x and y for each t value. First point is 9, -3. This is where 9, -3 is located. Then we will need 4, -1. So 4, -1 is this one. Then we will need 1, 1, which is right here. So if you just point these points and plug them in, this is what the parametric equation is going to look like for this example. Now, when we go to homework for 8.6, we have a total of 7 questions. The first one is pretty similar. We have x equals t minus 5 and y is equal to 2t squared, and t is between -1 and 1. So it comes in 2 parts. We're going to graph the curve and we're going to find the rectangular equation for the curve. So let's do this question on a piece of paper. X is equal to, for the homework, question 1, x is given as t minus 5. And then y is given as 2t squared, just 2t squared. And t is between -1 and +1. T is -1 to +1. So the domain for t is -1 to +1. So when I make a table, I will have a column for t, I will have a column for x, and I will have a column for y. And then when we place the t values, they start from -1, next integer is 0, and the last integer I can use is 1. I'm going to plug in these t values for the equation for x. X is t minus 5, so -1 minus 5 is -6, 0 minus 5 is -5, 1 minus 5 is -4. And then now we're going to calculate the corresponding y values. So when I plug in -1 here and square it, that's 1. 1 times 2 is 2. Now we're going to plug in a 0. 0 squared is 0. 0 times 2 is still a 0. When we plug in 1, 1 squared is 1. 1 times 2 is 2. Now, when we look at the x and y values, the first point is when x is -6 and y is 2. 1, 2, 3, 4, 5, 6, 1, 2. So this will be the first point. And then I'm going to need -5 and 0. So this is where -5 and 0 is located. Then I'm going to need -4 and +2, which is right here. And then I can just connect these curves and I'm going to get something looks like this. When I go to homework, whichever looks like this, or whichever the curve, when I look at this last curve, and then when I check this, the last curve has the points that I got. It has -6, 2, and -4, 2, and it has -5, 0. This will be the only one which has the points I got from the equation. Now, when I need to convert this to a rectangular equation, so here, so the B part of this question is now we're going to convert this to an equivalent rectangular equation. So in order to do this question, since x is given as, let's write it again, x is given as t minus 5. I want to just solve this equation for t. So if I just isolate the t, or if I add 5 to both sides, this equation can be organized in a way that t is equal to x plus 5. So in the y equation, where I see t, I can replace it with x plus 5. And originally, y was given as 2t squared. So y is equal to 2 will be copied, but instead of t, we can just write x plus 5 to the second power. So 2 will be copied here, and x plus 5 to the second power is x plus 5 times x plus 5. So if you want to, you can just multiply x plus 5 by itself in a different place. So this will give me x squared, and then this one will give me 5x, and then these two will give me 5x2, and then 5 times 5 is 25. These two are like terms, so when I am writing the answer for x plus 5 to the second power, I can simply write x squared plus 10x plus 25. Now, when I multiply this by 2, yes, it becomes 2x squared plus 20x plus 2 times 25 is 50. So this is what I need to get for this question. So when I go to the homework again, I can tell them the equivalent answer is 2x squared. What did we get? 2x squared plus 20x plus 50 plus 20x plus 50 is what I can get for this question for x over the interval. So now the given interval, one thing I need to highlight for this question is when I plugged in my answer to the homework as this one, it actually doesn't accept it. They want you to go further down and organize it, because when you finish your answer, the common factor is 2. And then actually, instead of going to this step, they just want you to stop here and then give the answer to them as 2 times x plus 5 to the second power. Now, you must also change the interval. This interval is for t. T changes from -1 to 1, but we have to modify this interval now for x. Since x is t minus 5, when t is -1, -1 minus 5 is -6. When t is +1, 1 minus 5 is -4. Therefore, the interval will also change as -6, -4 for the first question on the homework. For question 2, it's a very similar one, and you're going to follow the same path, creating a chart for a t, but the difference is t is not in a restricted interval. You can pick any number from -infinity to the infinity. You can definitely use the example button to understand what kind of t's you can plug in here to calculate the outputs for x and y, but they use some values from -2 to +2, like 5 sample values generated their x and y value. And then the difference will be here. These are going to be like a smooth curve. And because the interval is from -infinity to +infinity, the graphs will look like that too. And then when you need to also change this to a equation, so in this case, x is t cubed plus 2, and then y is 2 cubed minus 11 is what is given to you. Using the first equation, they got the t cubed all by itself. T cubed is equal to x minus 2. So when you go to the y, in the y, t cubed can change with x minus 2. So this is the original y equation. Replace the t cubed with x minus 2 and then put the minus 11. So y is equal to x minus 13 is what you need to get as a rectangular equation here. And then that's going to give you a graph of a line. So that's how we're going to do these questions, all similar, all the way to question 4. So for question 4, x is 21 cos t, y is 21 sin t. The question says find the rectangular equation for this plane curve, and then the parametric equation, the t is going to change from 0 to 2 pi. Again, you can click on this get more help, you can watch a video, you can go to the textbook, or the shortcut is if you click on example, the example is very similar to what you get as a problem, just the numbers are different, and then they explain with correct sentences. If I go over you how you're going to solve these questions, you're going to use a main trigonometric identity where sine squared plus cosine squared is equal to a 1. So when you see these questions, I'm going to continue this a little bit so I can explain you the process for these questions. When x is 10 cos t and y is 10 sine t, you're going to square your x on both sides. So x squared is 10 squared is 100, cosine t squared is cosine squared t. And then if you leave the cosine squared t alone here by dividing each side by 100, this is the equivalent expression for cosine squared t. Do the same thing for y. Y is given as 10 sine of t, square both sides, so you get y squared is equal to 100 sine squared t. Divide each side by 100, so sine squared t is equal to y squared over 100. Because sine squared and cosine squared will add up to a 1, you will add the x squared over 100 and y squared over 100, and you will set them to a 1, because that's always in trigonometry, sine squared and cosine squared of t will be equal to a 1. And now to change this to an equation that we are more familiar with, you're going to multiply both sides of the equation by 100. So you will get x squared plus y squared equals 100, which is very simple equation for us. This equation belongs to a circle whose center is at 0, 0, and its radius is 10. Therefore, when you want to graph this, you draw a circle where the center is located at 0, 0, and the radius is square root of 100, which is 10. Now the angle changes from 0 to 2 pi. That means that we're going to fit the circle in entire coordinate plane. And this is how we're going to do the question 4 in this homework. I believe question 5 is very similar, but the difference this time, 3 and 4, they're different numbers. So not necessarily you're going to get a circle here. You get a circle if x and y, they have the same number. But for question 5, x and y, they have different numbers. So this is going to get you an ellipsis rather than a circle, because if you follow the exact same process as question 4, and then you make your sine squared plus cosine squared equals to a 1 equation, using the same process, the denominators are different numbers. So to eliminate the denominator this time, we're going to have to multiply a different number, or you will have to recognize from the conic sections lesson that x squared over 4 plus y squared over 49 equals 1. It's actually an equation of an ellipsis. So this is what the graph is going to look like this, because the measured axis will be on the y-axis. And this is 49. So that means we're going to go all the way to 7 and negative 7 here, and 4. So you're going to go all the way to negative 2 and positive 2 here, since these are a squared and b squared in ellipsis equation. Again, if the explanations are not enough, you can click on the video and textbook, or you can click on help me solve this. For question 6 now, the question has changed a little bit. We are going to find two different parametric representations for the equation of the parabola. So we have a parabola equation given in rectangular system, which is y is equal to x plus 4 squared minus 7. And then for this parametric equation, we're going to let x to be t. So that means we're going to replace the x with t, so we can rewrite the y where x will change with t. So in this problem, instead of y, then I'm going to write t plus 4 to the power of 2 minus 7. This will be the expected answer for y. So basically, we're just changing x with y. Now for part B, now they want us to replace x with t minus 4, so we can rearrange the y. So instead of now x, I'm not going to simply write t, but instead of x, I'm just going to write t minus 4. So when I write t minus 4 with a plus 4, negative 4 and positive 4 will cancel out. And I'm just going to get t squared. And then there's a minus 7 at the end. for this part. And then that's how we're going to handle this question on the homework. Again, if this wasn't enough, please go here and then you can open a video which explains how to do these questions with a calculator. But you can also click on View an Example and then they will go through step by step how to do these questions for you. The last question here is very similar to what we finished. So first we're going to replace the x with t and then we're going to come up with a new equation here when in terms of t. So when I replace the x with t, the answer becomes t squared minus 2t plus 5. And then now we're going to replace the x with t plus 1. So basically we need t plus 1 to the second power minus 2 times t plus 1 and then plus 5. If I just leave my answer like this, I believe it's not going to accept this answer. Replace it, then simplify. So we have to expand this and then organize the like terms, and we're going to find when you square t plus 1 by itself, it actually gives you t squared plus 2t plus 1. And then when you multiply negative 3 by t plus 1, you get negative 3t minus 3 plus 5. And then when you add the 2t and negative 3t, that makes it a total of negative 1t. So you can just use a piece of paper to do this work. And then plus 1 and plus 5 and negative 3 will just give me a plus 3 for this question. And then if I didn't make any sign mistake, probably we made a mistake here with the last portion. And then it's just going to give you the answer for this one. You can just, when you expand it, you will find the right answer for number 7.